Hello students, welcome back to our object-oriented software engineering class. In today's session, we are going to learn about software development process models, specifically prescriptive process models. Whenever a software company develops an application, whether it is a banking system, an online shopping website, a hospital management system, or even a mobile application, the development team cannot simply start coding. There should be a proper plan or roadmap that guides the entire software development process. These roadmaps are called software process models. By the end of today's class, you will understand the different prescriptive process models, their advantages, limitations, and where they are applied in the software industry. In today's class, we will discuss the following topics. We will first understand what process models are, then move on to the prescriptive process models. After that, we will study the waterfall model, incremental model, evolutionary process model such as prototyping and spiral model, and finally the concurrent models. Each of these models follows a different approach for software development. First one is process models. Now let us understand what a process model is. Think of constructing a new house. Before starting construction, we prepare a blueprint, estimate the budget, plan the sequence of work, and allocate resources. Similarly, software development also requires proper planning. A software process model acts as a roadmap that guides software engineers through various stages such as requirement gathering, design, coding, testing, deployment, and maintenance. Without a process model, software projects may face delays, increased cost, poor quality, and customer dissatisfaction. There are different categories of software process models. In this course, we will mainly focus on prescriptive process models. Prescriptive process models provides a structured and disciplined approach for software development. They clearly define every activity that should be performed during software development. These activities include planning, software design, coding, testing, quality assurance, documentation, and change management. Today we will study 4 important prescriptive models: waterfall model, incremental process model, evolutionary process models, concurrent process model. Each model is suitable for different types of software projects. Let us begin with the waterfall model. The waterfall model is one of the oldest and simplest software development models. It follows a sequential approach. This means one phase must be completed before moving to the next phase. The phases includes requirement analysis, planning, design, implementation, testing, deployment, and maintenance. Imagine writing your university examination. You first read the question paper, then plan your answers, write them, review them, and finally submit the paper. Similarly, software development proceeds step by step. The waterfall model works well when customer requirements are very clear and are not expected to change during development. The V model is an improved version of waterfall model. The left side of the V represents software development activities. The right side represents testing activities. Every development phase has a corresponding testing phase. For example, requirement analysis is validated using acceptance testing. System design is verified through system testing. Coding is followed by unit testing. And the main objective of the V model is to ensure quality at every stage of development. So drawback of the waterfall model. So although the waterfall model is simple, it has several limitations. Real world software projects rarely have fixed requirements. Customers often change their requirements after seeing the initial software. Since testing happens only after implementation, defects are detected very late. Moreover, customers cannot see a working product until the end of the project. Because of these reasons, the waterfall model is not suitable for projects where requirements frequently change. Next one is incremental process model. To overcome the limitations of waterfall model, we have the incremental process model. Instead of delivering the complete software at once, the product is developed and delivered in small increments. The first version contains only the essential features, and after customers start using it, they provide feedback. Based on the feedback, developers add new features in the next release. Think about mobile application like WhatsApp. Initially, it offered only messaging. Later, voice calling, video calling, status updates, communities, and payment features were added. This is an excellent example of incremental software development. The biggest advantage is that customers receive useful software much earlier. Next one is evolutionary process model. As the name suggests, the software evolves gradually. Requirements may change because customer expectations, technology, and business needs continue to change. The first evolutionary model is prototyping. A prototype is an early working model of the software. Developers quickly build a simple version to demonstrate the basic functionality. Customers evaluate the prototype and provide feedback. Based on this feedback, developers improve the software repeatedly until the final product is ready. However, prototypes usually focus on demonstrating functionality rather than software quality. Prototype is a rudimentary working model of a product, usually built for demonstration purpose or as part of the development process. The prototype can serve as a first system. The first phase is communication. The prototype is deployed and evaluated by stakeholders. Based on the feedback, iteration of the further product development starts. So the drawback of prototype model, overall software quality or long-term maintainability are not considered. In prototypes, mostly inefficient algorithms are implemented simply to demonstrate capability. The second evolutionary model is the spiral model. The spiral model combines iterative development with risk management. Development proceeds in repeated cycle called spirals. During every cycle, developers identify risk, develop improved versions, receive customer feedback, and update project plans. The spiral model is particularly suitable for large, complex, and high-risk software projects. However, it requires experienced project managers because risk assessment plays a very important role. It may be difficult to convince customers that the evolutionary approach is controllable. It demands considerable risk assessment expertise and relies on this expertise for success. Next one is concurrent process model. It is also called as concurrent engineering. Unlike the waterfall model, different software development activities can happen simultaneously. For example, while one team is designing the software, another team may already begin testing an earlier model. If customers request modifications, the development process can immediately return to the communication phase without waiting for the entire project to finish. This model improves flexibility and reduces development time. Let us summarize today's class. We understood that software projects require proper planning through software process models. We studied 4 important prescriptive process models: waterfall model, V model, incremental process model, evolutionary process model, prototyping, and spiral models, concurrent models. Thank you everyone. In our next class, we will continue with more concept in object-oriented software engineering. See you in the next session.